Hello everyone. Today let us discuss about real numbers case study questions. Here we have a question. A piece of construction paper that measures 32 centimeters by 48 centimeters. We want to cut it into squares of equal size. Then first one we have to find out the dimensions of the largest possible square, and the second one how many squares can be made from that paper. So here whenever we want a largest possible square, dimension of a largest possible square from the given rectangular paper, we have to find out the HCF of the dimensions of the rectangle. That is HCF of 32 and 48. So given numbers are what? 32 and 48 are given. Then 32 can be written as 2 power 5 and 48 can be written as 16 into 3, 16 3 is a 48. Then that can be written further 2 power 4, 16 is 2 power 4, 3 power 1. So when we find out HCF of any two numbers, we take only common factors of common prime factors of two numbers. So here common prime factor of 32 and 48 is 2. So we write 2 and its lowest power is 4. So 2 power. So whenever we find out HCF, we take only common factors and their lowest powers. So 2 power 4, 2 power 4 is 16. So what is the first one conclusion? The largest, the dimension of dimensions of the largest possible square is 16 centimeters. Now the second question, how many such squares can be made from that paper, given paper? How many squares can be made? How do we know? The number of squares those can be made from that rectangular paper is area of rectangular paper, that is area of rectangle by area of square. So what is area of rectangle here? Length into breadth or breadth into length, that is 32 into 48 by side into side. Side is 16 we got, so 16 into 16. So further it is 16 1, 16 2s, 16 1, 16 3s. So 2 into 3, that is 6. So how many we can make? 6 squares can be made from given rectangular paper. Hope you understood this case study question. This is one question. Now let us see second question. So here second question, it is about the marbles in a bag are divided evenly between two friends. There is one marble left over. Means what? When those marbles are distributed equally for two people, one marble is left over. Means when you divide that number by 2, we get remainder 1. Similarly, when the same number of marbles are divided evenly among three friends, there is one marble left over. So that means what? When these number of marbles are distributed between three members also, one is left over. When the marbles are divided evenly among five friends, there is one marble left over. So what? Here it is given, let us take there are x marbles. Oh, these x number of marbles are divided between first time two people, we get one left over. When second time they are divided to three people, again one is left over. When they are distributed among five people also, one is left over. So by this what you should understand? that number x is divided exactly by 2, 3, 5. It is not exactly divided by 2, 3, 5, but it is leaving remainder 1 when you are dividing x by 2, 3, 5. So what? To find out that number x, we have to find out HCF of, no, no, LCM of, because all that number should be divided by 2, 3, 5. So we have to find out common multiple of 2, 3, 5. So you should find LCM of 2, 3 and 5. Then whatever result we get, that result should be added by 1. So now the LCM of 2, 3, 5 is what? Because all these numbers do not have any common factor, LCM is 2 into 3 into 5, which is 30. Now you can see 30 is exactly divided by 2, 30 is exactly divided by 3, 30 is also exactly divided by 5. But every time we need to have one more marble that is left over. So what? The number of marbles in the bag. How we get number of marbles in the bag? Number of marbles in the bag will be equal to 30 plus 1. That is what? 31. Then now we can check. When you divide 31 by 2, 1 will be left over. When you divide by 31 by 3, 1 will be left over. When you divide it 31 by 5 also, 1 will be left over. So 31 is our required number. This is the first question answer. What is the second question answer? What is another possible number of marbles in the bag? Another possible numbers are what? 61 can be there. This is the least one, least possible number. This is least possible number. Other possible numbers are 61, then 91, 121, so on like this. So all these numbers will leave you remainder 1 when you are dividing by 2, 3, 5. This is the second case study question. Hope you understood it. Now let us see what is third question. Now let's see the question number 3. Last year my grandmother was admitted Fortis hospital due to a small accident. She was prescribed a pain medication to be given every 4 hours and an antibiotic to be given every 5 hours. Bandages applied to the my grandmother's external injuries needed to change every 12 hours. The nurse changed the bandages and gave my grandmother both medications at 6 a.m. Monday morning. And first question, how many hours will pass before the grandmother is given both medications and has her bandages changed at the same time? So here what we have to find out? We have to find out the number of hours after number of hours before the grandmother is given both medications and her bandages changed at the same time. So we have to find out all the three together when they were changed. So we need to find out LCM of 4, 5, 12. So in this case, what you have to find in this type of situation, you have to find LCM of 4, 5, 12. So we know 4 is equal to 2 power 2 and 5 is equal to 5 power 1, but 12 is equal to 2 power 2 into 3 power 1, 4 into 3. So what? LCM of 4, 5, 12 is equal to, we have to write the different factors 2, 3 and 5, all different factors we have to write first we have to write all the different prime factors in the given factorizations and then their highest powers. Highest power of 2 is 2, highest power of 3 is 1, highest power of 5 is also 1. So this is 4 3s are 12, 5 is 60 hours. So what is the first one answer? After, before 60 hours before, 60 hours before the grandmother is given, 60 hours before grandmother is given both medication and her bandages changed. Now second question is what in this? What day and time? So next question is what day and time will this be? So in question it is mentioned that all the three were given at 6 a.m. Monday morning. So now the 60 hours should be added to 6 a.m. Monday morning. 60 hours of time is nothing but what? 48 hours plus 12 hours means what? 48 hours is nothing but 2 days plus 12 hours. 2 days. So we have to add these 2 days to Monday. Then what it will be? Tuesday and Wednesday. Tuesday 6 a.m. Wednesday 6 a.m. plus 12 hours. Then what it will be? Wednesday 6 a.m. plus 12 hours is nothing but Wednesday 6 p.m. So therefore Wednesday at 6 p.m. Let's see this question. Question number 4. Here question is about Lavanya wants to organize her birthday party. She is very happy on her birthday party. She is very health conscious. Thus, she decided to serve fruits only in her birthday party. So she want only fruits to distribute. She has 36 apples and 60 bananas at home and decided to serve them. She wants to distribute fruits among guests. She does not want to discriminate among guests. So she decided to distribute fruits equally among all. So here first question based on information. First question is how many maximum guests Lavanya can invite. So here Lavanya is having 36 apples and 60 bananas, and she want to distribute these 36 apples and 60 bananas equally among all the guests, and that number should be maximum. How many maximum guests she can distribute these two types of fruits equally? So we have to find out HCF here because these two should be divided, and these two should be divided by a maximum number, highest number. So we have to find out HCF of 36 and 60. So let us write the factorization of 36. 36 is 4 into 9, 4 is 2 power 2 and 9 is 3 power 2. So prime factorization of 36 is 2 power 2 into 3 power 2. Similarly 60, prime factorization of 60, 60 can be written as 12 into 5. 12 is again 2 power 2 into 3 power 1, 4 into 3, 2 power 2 into 3 power 1, 12 into 5 power 1, 60. So these are the prime factorization of 36 and 60. Now we want HCF of 36 comma 60. Whenever we find out HCF, we take only common prime factors. So here prime factors are 2 comma 3 because these two are there in both the factorization. So you have to take 2 into 3. After that we have to select their lowest powers. Lowest power of 2 is, in both the cases we have 2 only. So lowest power of 2 we have to take 2, and lowest power of 3 is 1. Here 1 is there. So lowest power of 3 is 1. So 2 power 2 into 3 power 1. 2 power 2 into 3 power 1 is 4 into 3. 4 into 3 is 12. So she can invite maximum 12 guests so that she can distribute fruits equally. Next question, how many apples and bananas will each guest will get? So second question, total 12 guests are there. Each guest how many apples and how many bananas they get, we have to find out. So total 36 apples are there, 12 guests are there. So you have to divide 36 with 12. You get 12 ones are 12 threes are. So 3 apples. Each guest will get 3 apples and 60 bananas are there. So 60 by 12. 60 by 12, 12 ones are 12 fives are. So 5 bananas each guest will get. So what is the conclusion for second question? Each guest will get 3 apples and 5 bananas. Second question conclusion. Third question, in question number 3, Lavanya decided to add 42 mangoes also. In this case, how many maximum guests Lavanya can invite? Here one more number is added. Before we were having 36, 60 and now one more 42 is also there. Now we have to find out HCF of these three numbers. So we already know 36. 36 is 2 power 2 into 3 power 2 and 60 is 2 power 2 into 3 power 1 into 5 power 1. Now 42 is added. So 42 is 6 into 7. 6 is 2 into 3. 2 into 3, 6 into 7. So 2 power 1, 3 power 1, 7 power 1. Now we have to find out HCF of these three: 36, 60 and 42. Again same method, we have to take the common factors. Common factors are same again, 2 and 3. 2 and 3 are there in all the factorizations. So 2 into 3. But in this case, the lowest power of 2 is 1. Lowest power of 2 is 1. Lowest power of 3 is also 1. So what it is? 2 power 1 into 3 power 1, which is 6. So in this case, how many maximum guests she can invite? In this case, she can invite only six guests. She can invite maximum 6 guests. Question number 4. What happened in question number 4? How many total fruits will each guest will get? After she is having 36, 60, 42, how many total number of fruits each guest will get? So again same, 36 by total 36 apples are there, 6 guests are there. So 6 ones are 6 six are. So 6 apples, 60 bananas. So 60 divided by 6, 10 bananas each one will get. Next one more, 42, 42 by 6. So 6 ones are 6 sevens are. So what? 7 mangoes. 7 mangoes each guest will get. So total they are asking now, not separately. Total number of fruits. So the total number of fruits will be what? 6 plus 10 plus 7, which is 23. So each guest will get 23 fruits. Will get total 23 fruits. Question number 5. What happened in question number 5? She decided to add 3 more mangoes. Already she is having 42 mangoes with her. Now 3 more are added. Total 45 mangoes will be there with her now. And she removed 6 apples in total fruits. So she was having 36 before. Now 6 are removed. Now 30 apples will be there with her. 30 apples. In this case, how many maximum guests Lavanya can invite? That by this, what you should understand, the number of bananas are as usual. 60 bananas are there. There is no change in bananas. Now we have to find out the LCM of 45, then 30 and 60. 45 is 9 into 5. 9 is 3 power 2 into 5 power 1. 30 is 6 into 5, 6 is 2 into 3 into 5, 2 power 1, 3 power 1, 5 power 1. 12 already we wrote before, 12 into 5, that is 2 power 2 into 3 power 1 into 5 power 1. Now again we have to find HCF of 45, 30 and 60. So again we have to find out the common factors. Now we can observe there is no 2 in all the factorizations. We have 3 in all the factorizations. We also have 5 in all factorizations. So common factors are 3 into 5. Now we have to select their lowest powers. Lowest power of 3 is 1. Lowest power of 5 is also 1. So 3 power 1 into 5 power 1 is 15. So in this case she can invite maximum 15 guests. Hope you understood this problem. Now let us see one more case study question. Now this is question number 5. In this question, Shalvi is a tuition teacher and teaches mathematics to some kids at her home. She is very innovative and always plan new games to make her students learn concepts. Today she has planned a prime number game. She announced the number 2 in her class and asked the first student to multiply it by a prime number and then pass it to second student. Second student also multiplied by a prime number and it passed it to third students. In this way, by multiplying to a prime number, the last student got 1,73,250. The last student, the number got 1,73,250. He told this number to Shalvi in class. Now she asked some questions to the students as given below. First question, how many students are there in the class? So to know this, how many prime factors are there in that, you have to know, because every student multiplied a prime number. So how many prime factors are there? We have to find out. So let us find out the prime factorization of 1,73,250. So shall we already gave 2. So let us start with 2. 2 8s are 16. 1 will be left over. 1 3 13. So 2 6 are 12. Again 1 will be left over. 2 6 are 12. Now 2 2s are 4. 1 0 10. So 2 5s are 10. Now we can divide it by 3 number. 3. So 3 2s are 6. 2 will be left over. 2 6 26. So 3 8s are 24. Again 2 will be left. 2 6 26. Again 2 8s are 3 8s are 24. Again 2 will be left. 2 2 22. 3 7s are 21. Now 1 will be left. 1 5 15. 3 5s are 15. Now again we can divide by 3 table because sum of the digits is divisible by 3. Now 3 table again. 3 9s are 27. 1 will be left. 1 8 18. 3 6 are 18. Now 7 is there. 3 2s are 6. Now 1 will be left. 1 5 15. So 3 5s are 15. Now again, now we cannot divide by 3 table because sum of digits is not divisible by 3. So we can follow by 5. 5 table if you do, 5 1s are 5, 4 6 46, 5 9s are 45, 1 2 12, 5 2s are 10, 2 5 25, 5 5s are 25. Again we can do by 5 table, 5 3s are 15, 4 will be left, 4 2 42, so 5 8s are 40, 2 will be left, 2 5 25, 5 5s are 25. Again by 5 table we can do it, 5 7s are 35, 3 will be left, 3 5 35, again 5 7s are 35. Now 7 table, 7 11s are 77. If you want one more time we can write like this. Now what we got 1,73,250 is equal to 2 power 1 into 3 power 2 into 5 power 3 into 7 power 1 into 11 power 1. This is the prime factorization. So here total how many prime numbers are repeated in this? 3 is there. Already 2 is given by Shalvi. Remaining how many are there? We have to find out. 3 2 times it is there. 5 3 times it is there. 7 one time it is there. 11 one time it is there. So how many numbers? One student is multiplied by 3. Again one more student also multiplied by 3. Next 3 students are multiplied by 5. Next 2 are multiplied by 7. So total how many? 1 2 3 4 5 6 7. Other than 2. Why we should not take 2? Because 2 is given by Shalvi and remaining 7 students are involved in this game. So question number 1, 7 students are there in the class. Hope you understood this question number 1. Now question number 2, what is the highest prime number used by student? What is the highest prime number used by student? What is the highest prime number in this? 11 is the highest prime number. So question number 2, 11 is the highest prime number used by student. Now question number 3, what is the least prime number used by students? What is the least prime number used by students? 2 is given by Shalvi, so 2 we should not consider. Other than 2, what is the number we have? 3. So we have to write 3 is the least prime number used by student. Next, question number 4. Question number 4 is what? Which prime number has been used maximum times? Which prime number is used maximum times? 5. Because 5 power 3 is there. 3 times it is used. So 5 is used maximum number of times. Five is used maximum number of times. That is 3 times. Next, which prime number has been used minimum number of times? Which prime number is used minimum number of times? There are 2, 7 and 11. Both are used minimum number of times. 7, 11 are used minimum number of times. Hope you understood this solution also, and it will help you to write competency based questions, case study questions in your boards. Thank you.